Hi, Andrea.
So again, would you like to give us
Yes.
some extra
Yes,
information
sure.
for today's session?
Yes. So we are having this meeting on Zoom, and so you can talk either in the chat, but we'd like you to ask your question on Slido. You have the QR code if you want to join with your mobile, sorry, and you can also use the number that's on the screen here. So on the Slido, you will be able to ask all your questions, and after the presentation of the experts, we'll answer these questions. We'll try to answer as many as we can, but all the questions will be answered afterwards. We'll send you a file with all the answers to your questions. So here's the agenda for today's session. We're having right now the welcome and agenda presentation. Then Andrea will present you the Copernicus Marine Service. We'll have the presentation of the products, so satellite and model products. The in situ won't be presented today, but we'll have a small talk, I hope, from some of the experts. We'll have then several user testimonies, a user corner and e-learning material available presentation, and then a little teaser of tomorrow's session, so workshop day 2. And at the end of the workshops, the experts will stay with us and they will answer our questions, and we'll be able to have free talk with them.
Great. A good session ahead.
Yeah, and the link to the Slido has been sent via the chat, so you can ask your question also via the link on the chat.
Great. Yeah, so don't hesitate to leave your questions. We'll try to answer them all. Okay, so let's start with the Copernicus Marine Service. Let me introduce you to this service. This is one of the 6 services of the Copernicus program. This is the European Union's program dedicated to the observation of the Earth. The goal is to monitor the state of the planet and provide data and information, free access to all of this data to everyone. The Copernicus Marine Service dedicates, of course, to the monitoring of the marine environment. So what kind of data can you find is the Copernicus Marine Service providing? Is providing data related to the physical aspect of the ocean. So we call it the blue ocean. It provides information and data related to the white ocean, so the sea ice, and also provides data related to the biogeochemical aspects of the ocean, or the green ocean. How can you access Copernicus Marine Service and all our products? You have one single access point. It's our website, marine.copernicus.eu. You will have a vast catalog of products, more than 300 scientifically verified products you will find in there. You only have to register. All these products have a user-driven approach. That means we try to take into account feedback from users and also the needs that users have, and to take this input to continuously evolve our service. Our data has only one type of format, NetCDF, which makes it very useful and very easy to use all the products. And as I said before, it's all open and free for everyone. When it comes to the data sets, there's a combination of different data sources in our data sets. They can provide from model data in situ or satellites. We'll have more details later through our speakers today. There's a variety of temporal coverage in our products as well. There are reanalyses prior, 25 years prior. There's a real-time data where there's daily and hourly updates. And there's also through model data, we also have forecasts from 5 to 2 days. The Copernicus Marine Service covers the global ocean, but also 6 other regions in the European regions. So besides our products, we also diffuse information. We have the Ocean State Report, which is a yearly report on the state of the ocean, providing summarized information and accessible for different publics. We also have ocean monitoring indicators, and we also have visualization tools, which is the example of My Ocean Viewer. We will have a demonstration tomorrow made by Martin. And when it comes to the different sectors who are using these products, who is this data serving? So very different sectors of the world and of the society. We have environmental sectors where we can have monitoring of the ocean, of the health of the ocean, for marine conservation, for polar environment monitoring. We can also have other sectors such as education, research, policies, policy and ocean governance, but also other sectors more related to economy, such as marine food and coastal services, navigation, etc., etc. You will have also more examples via our user testimonies later, where you will be able to see a clearer idea of how this data can be applied. We want you to know how to use our product, so we organize workshops like this one, training sessions, webinars, and we participate in other masters and online courses and hackathons to be able to help you use our product. We are available on social media, so you can follow our Twitter account, our YouTube page, where you can also check our last trainings and follow a bit what is going on. What are we organizing at the moment, so you can be ready and participate in the next ones. Thank you for your attention. And
thank you, Andrea. Okay, so we're now moving on to the products overview. Before starting, maybe the Institute Tech would like to introduce themselves because they are not having a proper presentation today. I don't know if someone is here.
Yes, I'm here.
Okay, hi.
Anna from BSH. So I'm going to start my video. Okay, so yeah, good afternoon, everyone. Unfortunately, we don't have a presentation, a dedicated presentation for you from the Institute Tech side. But anyway, it's worth that we introduce ourselves and how we contribute to Siemens, to the Norway Shelf. So the in-situ tag, what we do is we access, quality control, homogenize, and distribute in-situ data. So we directly go to the providers, we get the data from them, and we distribute them to the Siemens users through the web portal services. There's mainly 2 data streams in the in-situ tag. So we have the near real-time data stream, in which we apply real-time quality control, which are all agreed within all the tags. And there's also a reprocessed data stream. And that stream, there are several scientific expert groups dedicated to sea level, waves, or biogeochemistry. And every 6 months, there's a temporal station. So that's a really qualified, a good quality control data from these observations. The Norway Shelf in-situ tag is based in Hamburg, in Germany, and is hosted by the Federal Maritime and Hydrographic Agency. So we will be with you through all the training. So any questions, we will be happy to help.
Yeah, thank you, Irene, for your presentation. We're moving on to Vinka Rosmatek, who's going to present us the first presentation of satellite observation. Hi, Vinka. Welcome.
Hi.
Thank you for being with us.
Thank you. Welcome to everybody. So I will talk to you about the satellite products. sharing my screen. It's okay?
Just if you could put in presentation mode, Vinka.
Yeah, I am.
There's always something missing. It's normal.
And I can't find my mouse anymore.
Yes, we see your screen.
It's okay?
Not yet on presentation mode.
Yeah.
But maybe we can also just continue like this. You can go ahead, Vinka.
Okay. Strange because 10 minutes ago it was working. So the outlines, you see the outlines or not?
Yes, we do.
Yeah, okay. On the outline, I will talk to you about thematic assembly centers, the different satellite observation project, and the 3 stacks thematic assembly center with specific data on North Wales Shelf. So the sea level thematic assembly center, the sea surface temperature one, and the ocean color, and briefly show you other assembly centers with also global satellites data. So the Copernicus Marine Service is organized through marine forecasting centers, which are delivering forecasting and model data, and a thematic assembly center, which are providing observation either satellite or in situ. So Irene was talking about the in situ thematic assembly center, and I will talk about satellite thematic assembly center. For each and every product, you have information on the product user manual, the PUME, and also on the quality document, the QUILs. For the 8 thematic assembly centers are the ice, wind, sea level, in situ, ocean color, SST, wave, and also multi-observation tags. So they have different regions, as Andrea told. So here we will talk about North Wales Shelf, but in fact, a number of satellite products are grouped with European seas. So North Wales Shelf, Iberic Biscay Islands, and Med Sea, and some grouping like that. So you have also the near real-time products, which are available within 1 day delay.
Sorry, Vinka. Sorry to interrupt you. We don't see the slides passing. I don't know if you're switching them or.
Yeah, that's why I was asking earlier, because it happened already once.
Oh yes, now it's working.
Okay.
Let's try to continue. Thank you.
We'll fine. We'll continue without. So that was what I was showing earlier. It's different thematic assembly centers. And now it's different regions with near real time for operational use with data available within 1 day after the measurement by the satellite or in situ. And the multi-year products, which are long homogeneous time series, which are updated every about 6 months and of higher quality. So if you want to work on operational use, you will use NRT data. If you want to work on a more long-term study, you'd better use the multi-year product. You also have the notion of levels of products. So you have the level 2 pre-processed with only some of the measurement selected and an homogeneous processing between the different sensor, meaning the different satellites, in fact, which is more disseminated through Copernicus Marine Service. You have the level 3, which are products generated by other projecting data onto a homogeneous repetitive lat long scheme with different files from the level before. We are aggregating files per day instead of per orbit, and or intercalibrating the sensors. Depending on the tag, you've got either L3 dot or L3U, L3C, or L3S, depending on the product. And you have also all those steps together, the L3 without any more mention, depending on the variable. You've got the level 4, which are, to be honest, the most used. There are gap-free grids. There are no missing data points, either because there wasn't any measurement or because you've got you had clouds, for examples, for ocean color. In sea level TAC, the multi-sensor gridding is done at these steps, and the last level of data are the ocean monitoring indicators with trends and data sets covering the past quarter of a century. So I've illustrated them for the sea level TAC. So you see on top different maps covering done by different satellites. The L3 with an homogeneous processing of the different satellites, but still only along the track of the satellite, which is a specificity of the sea level. You only have the data underneath the satellite. You've got the level 4, which is computed from several days and several satellites all together to have a fully filled grid here on the Mediterranean, but it could be done on the Northwest Shelf, of course, and the ocean monitoring indicator. So left, you've got the mean sea level trend. The sea level is rising, and so the sea level satellites are measuring this, and the map of this trend all over the last 30 years of measurements. So for the sea level is measured by the satellites measuring the distance between itself and the surface of the ocean on one side, and having different orbit altitude measurement instruments. So knowing those two quantities, we can have we can deduce information like the absolute dynamic topography, the sea level anomalies, mean sea surface height, and and from those sea level anomalies and absolute dynamic topography, we can compute also the surface geostrophic velocities from the surface slopes. So those are reference to different reference surfaces, either an ellipsoid of reference, which is purely geometrical shape, geoid, which is the shape of the Earth if only gravity was giving it shape, and also the mean sea surface, or the mean dynamic topography, which are means of those quantities all over the years. For the sea level TAC, over the Northwest Shelf, you've got 2 products in near real time and 3 in reprocessed or multi-year data. Each time you've got the level 3, meaning along track, you only have this thin thread of data, or the level 4, the gridded data. With a spatial resolution for the level 3, we've got 2 different spatial resolution every 7 kilometer. Got 1 point every 7 kilometer, and in fact it's every second. Or we've got now high resolution data with every about 1 kilometer, with which are available only in reprocessed mode. And the grids are available either in near real time or in reprocessed. Just a quick word on those high resolution data. It's a quite new data set on Marine Copernicus service. So we have the use in altimetry in sea level is to provide data 1 measurement per second. However, those are already average data. So we are reprocessing them so as to average only 5 per second. And this time we can have about 1 point every kilometer. So it's available on North Atlantic, and we would welcome feedbacks on those products. The sea surface temperature now. The sea surface temperature are measured either by infrared sensor or microwave ones. There's different definition of the sea surface temperature. With the skin temperature, which is a very first micrometer of the ocean, subskin from the microwave sensor, or foundation SST, which is temperature free of diurnal warming. So you can have those different sea surface temperature in some of the products, or either of them. So take care of the data and the name of the variables. So for the sea surface temperature, you've got the L3S fields and the L4 fields with high spatial resolution of 0.02 degrees or 0.05 degrees by daily at night with near real time and reprocessed data. With a very long time series for the reprocessed data, since you've got data since 82. The ocean color is observing the ocean color by measuring the solar reflected radiation. So it's only by day, and it can go through the clouds. And you have different quantity which are deduced from the ocean color. You've got optical variables such as particulate bulk scattering, the diffuse attenuation, reflectance, or biological, which are deduced from typically the chlorophyll from the green in the reflected radiations, primary production, phytoplankton, suspended matter, and things like that. So depending on the product, you can have some or all of those variables provided within a file. So you've got the L3 and the L4 here also, in near real time and in reprocessed mode, with, as I've sorted, plankton, reflectance, transparency in optic for level 3, biogeochemical in levels 3 and 4, plankton and transparency at given resolution on monthly basis, and biogeochemical at 4 kilometer, 1 kilometer, and 300 meters daily and monthly. Here also in both near real time and reprocessed mode. So every single one of those products are of course available through the catalog. And a little word on the different global only data sets, which are available through the Marine Copernicus catalog. But of course, if they are global, they have data on North Wales Shelf. So you've got the wind data from scatterometer or from altimetry satellites, also from, could have some from sensors. You've got also model data, but the wave track with data from synthetic aperture radar or altimetry satellite, also in situ, and all those models are assimilating, and models assimilating those observation data. And you've got also satellite data in the multi-observation thematic assembly center. In this assembly center, you've got combination of data either different satellites or in situ and satellite and fusion data. You've got also physical, geochemical and carbon product, but also current speeds, velocities, and different data, including in-depth computed from a mix of in situ and satellites. And with all those data, of course, you can do some assimilation in models. You can do some pollution monitoring. You can help in understanding the marine animals' behavior. And you can study, basically, if I can say that, the ocean dynamics. So that was all from me. If you've got questions, I'll be happy to answer them.
Thank you, Vinka. Thank you for your presentation. When it comes to the questions, we wanted to remind everyone you can drop your questions in Slido. We have sent the link. That's where we're gonna collect the questions and ask our experts. Maybe we could pass directly to Rian Zhizeng, and then we will answer the questions related to the satellite products all together. So if you can just share your screen.
Thank you. I'll start sharing. Yes, can you see it in presentation mode?
Yes.
Okay, thank you. Okay. So my name is Rianne Giese. I'm working as a research scientist at the Royal Netherlands Meteorological Institute, and we provide ocean surface wind products derived from satellite observations to the Copernicus Marine Service. So I will tell you a bit more about these products in this presentation. These products are all derived from scatterometer observations. Before, we also used some altimeter data, but in the current products, these are only based on scatterometer observations. It may, of course, change again in the future. And scatterometers are active satellite instruments that send a microwave signal to the surface and then measure how much of this wave is returned to the instrument. And if you look at the ocean surface, then there's very small waves, so not the big waves, but the very small waves on top on the other of the larger waves, which scatter the signal, and depending on how rough the surface is, more or less of this signal is scattered back to the satellite. So in case of a very smooth surface, most of or actually all of the signal is reflected in a forward direction. So there's nothing returned to the satellite. And if the surface gets rougher, a larger and larger portion is returned back to the satellite. And we use relations between the returned signal, the backscatter, and wind speeds to derive wind speed from the backscatter signal. So there's different types of instruments. For example, there's a fan beam scatterometer that's kind of scanning back and forth. And there's also pencil beam scatterometers that measure more in a circle. And they both have their advantages and disadvantages. But because they look in different directions and have the multiple antennas, they can also derive, we can also derive the wind direction from the measurements as well. And then there's also two types of frequencies that are being used. So C-band, which is the longer wavelength, which is not sensitive to rain. So even when it's raining, we can derive the wind speeds at the surface, but it has some limitations at determining the wind speeds when it's for really extreme wind speeds. And on the other hand, there's Ku band sensors, which have use a shorter wavelength, but these are sensitive to rain. So when it's raining, where the satellite is looking, then we cannot trust the wind speeds that are derived. So these cannot be, they're flagged in the products. But these again have less limitations at extreme wind speeds. So there have been quite a number of scatterometer missions in the past. This is not a full overview, but actually the scatterometers that we use in our product. So there's the ones that have at least a record for a couple of, quite a long time. So the first scatterometers were was launched in 1992, which is ERS. Then there was a follow-up with the next ERS scatterometer. These both are C-band scatterometers, and then there was a long period covered by the QuickScat scatterometer, which is a Ku band scatterometer. Then there was a sequence of three three scatterometers on the METOP satellites, METOP A, B, and C, of which the B and C are still operational. And there are some additional Ku band sensors, OceanSat-2, which is had the OSCAT instrument, and also SCATSat, which also had an OSCAT instrument. And currently there's also three Chinese scatterometers that we use in our products. So for the multi-year product that we have with the level 3 product, we use the upper ones with the in the orange box, which have long records, and for the near real time product, which starts in 2016, we use all the instruments that are in the green box. And currently we actually have 5 different instruments that are operational. So that's really a record, and has very nice applications. So here I'd like to show to give you an idea of the scatterometer coverage, specifically also for the Northwest Shelf region, for the 5 scatterometers that are currently operational and in our near real-time product. So these are both the ascending and descending orbits, and they show the daily coverage. So this is an arbitrary day. It's a day selected last week, and these are all showing zonal wind. I will show what other variables are available in the next slide. So there's not full coverage for each satellite. For the Haiyang satellites, they have a wider orbit, so they actually provide almost full coverage, especially if you combine the ascending and descending tracks. But you can also see that some data is being masked because of rain occurring in the satellite within the satellite beam. And for the METOP B and METOP C, they have we also have a higher resolution product up to 1/8 of a degree, but then the orbits are less wide, so you need to combine some either 2 instruments or ascending and descending tracks to have a full coverage. But these satellites also pass over different times of day, so they also give a more like a time series over the day if you combine them. So there's quite a number of variables included in the level 3 products. I already showed the zonal wind components, but we also have the meridional components, the magnitude of the wind, the wind speed, also wind direction, which is not shown here. And then we also calculate the spatial derivatives of the wind fields, the divergence and the rotation, which can be useful for some applications. And we do the same for the ocean surface wind stress. So we also provide all the same variables except for the direction because it's directly related to the wind direction. And additional to these variables that we provide for the spectrometer observations, we also include in the products the collocated. Well, for each observation we actually look at the ESMWF model and take the nearest model value that corresponds to that observation in location and time, and we also add it to the product. So we call that collocated values. And for the neural time product, that's from the operational ESMWF model, and for the multi-year products, it's from the ERA 5 reanalysis. So, and the reason to do this is to, on the one hand, by looking at the collocated model values that are sampled in the same way as the observations, and compare that to the full ESMWF model field, you can get an idea of the sampling error that's in the spectrometer observations. And on the other hand, we can use look at the difference between the two and get an idea of the biases in a model. So that's what I will be talking about now, because there has been a study where these biases have been calculated between METOP A, ASCAT, and the ERA 5 reanalysis, and then averaged over 1 year. And then you see that there's actually quite a persistent pattern. So it's not that it's random differences, but in some locations, there's always, or at least average over a year, there is a bias that is there. So for the zonal winds, for example, there's positive biases in the tropical regions and negative biases in the mid-latitudes. And for meridional winds, it's a bit different again. But especially in the tropical regions, these biases are large. And also, if you look at the wind variability, what we here call it transient wind, we found that there's actually a lot more wind variability in the observations compared to the model. So we used these results to create level 4 products. Well, I'll tell you a bit more about the methodology behind that. So because for a level 4 product, in our case, it's a combination of observations, satellite observations, and model values. And what we do, we calculate this bias over a multi-day period, in this case, a 20-day period. And we calculate the difference for every location. We average all the differences in the spatial sense. So that gives the figure on the left as an example. This is for the tropical Atlantic, where we find very large biases. And then we add this bias to every hourly ESMWF model field. So every hourly field is corrected for the corresponding bias. And in these figures, it's not very clear to see that the field really changes. If you really look at the details, you can see that the local gradients change and also the larger gradients change. But because the bias is quite large, it's up to meters per second, but on the other hand, it's still relatively small compared to the speeds observed, and it's not very clear in the figures. So also looking particularly at the Northwest Shelf, biases can also be large. This is just an example for 1 day, I think in 2022. But anyway, biases can be up to plus or minus 1 meter per second, but because the winds are large, you don't really see it. But if you look over a longer period, because these biases are persistent, they do really make a change. What we offer in our level 4 products is a neural time product where we use the hourly ESMWF operational wind fields, and then we apply a bias correction based on a combination of METOP B and METOP C. And this product is available from 2 years before now until yesterday. So today you can download the products from yesterday. And of course, these are all global fields, but also available for the Northwest Shelf. And they're on an 1/8 of a degree horizontal grid. And then there's also a multi-year product, which is based on ERA 5 reanalysis wind fields. And then the corrections are based on different combinations because we go further back in time. So we have to use different satellites. So one is, the product now starts in 2007 with METOP A, and then there's a combination of METOP A and B from 2011 onwards until the end of METOP A, when we switch to METOP B and METOP C, which is the combination that is used now for the bias correction. It's also on a 1/8 of a degree horizontal grid, and we're now working to also add data sets for the earlier periods based on QuickScat, sea winds, and on the ERS satellites. And these are planned to be added this year. And then we have another level 4 product, which is a monthly product, and that's based on the same principle. So it includes a bias correction based on monthly differences between spectrometer observations and collocated model values. And then we add that to the monthly mean fields from ECMWF. And it does provide more detail in the monthly averages because these biases are so persistent. And we compared the monthly product to buoy observations for the entire period from 2007 until recently. So compare them to every monthly average buoy observations. And if you compare the upper row to the lower row, the upper row is the difference between ERA 5 and the buoys, and the lower row between the monthly product and the buoys, both for zonal wind difference on the left and meridional wind difference on the right. Then there's particularly an improvement, for example, on the east coast of the US and also in the tropical Atlantic, but unfortunately, the changes are not very large for the Northwest Shelf region. So there are some improvements here and there, but they're not that clear. So that's something also for us to look into a bit further. And that's my presentation. So thank you for your attention, and I'd be happy to answer any questions that you may have.
Thank you very much, Rian. I can tell by the comments on the chat that people liked your presentation. Thank you very much. And we also had many questions. We won't be able to answer them all, but maybe we can answer the first two questions. I think they are for Vinka more than for Rian. Which kind of interpolation is applied to pass from level 3 to level 4 gap-free data, Vinka?
In the sea level case, I'm afraid I don't exactly know the processing for the ocean color or sea surface temperature, but for the sea level, we are using for now optimal interpolation. We are investigating other ways of interpolating currently, but the data you'll have as level 4 are optimal interpolation.
Okay, thank you. And
sorry, that's
that's great. And maybe
you have article describing them, which are available. I think the references must be in the product user manuals or the quality or the quid if you want more information.
Okay, great. And so maybe a second question, since errors are often observed in the coastal zone using altimetric data, which approach is used to reduce its errors? That's a big question.
Yeah, that's a very big question, I'm afraid. In part, we are not using the radiometer correction, but a model close to the coast, because the radiometer in sensor, which is on board and which is meant to correct from the effect of water in the atmosphere. has a very big ground footprint. So if closer to the coast, we've got a mix of water and land. That's the whole point of close to the coast, is that you may have a mix of land and water in what the sensor gets back. So for the altimeter proper, one of the approach is the high resolution data I've been talking about. We are computing more precise data, more high resolution data, so that you can get a bit closer to the coast with the data we provide in level 3. And for now, we are doing a lot of studies to improve the coastal data. So you'll have regular and operational coastal data from altimetry in the future, but for now, there are more errors close to the coast.
Okay, great. So there are still many questions left to be answered. Just to remind you that we will answer them all. All the experts will answer your questions, and we'll give you the answers as soon as possible. I think we're moving on to the next presentation, Andrea.
Yes, we are. I will
With Jen.
exactly. I will just share my screen. Or actually, Jonathan, you can go ahead and share directly your screen. We're going to have Jonathan from Met Office, the National Meteorological Institute of the United Kingdom, and will tell us more about model products in the Copernicus Marine Service. Whenever you're ready, Jonathan. I don't know if you're trying to speak, Jonathan, but we cannot hear you. Hello, Jonathan, can you hear us?
Can you?
Perfect. C'est moi?
No, we can't hear you.
No.
We can't really hear you,
Oh,
Jonathan.
okay.
Sorry.
Still not. Ah, that's strange.
Jonathan, maybe on your audio icon, you can choose the source of your audio with the small arrow. One, two, 1, 2.
Can you hear me?
Ah,
Yeah.
yes.
Okay.
Good.
Okay, I'll forget about the headset.
Ah,
Sorry,
yeah.
that was working when we tried a few minutes ago. So I'm Jonathan Tinker. I manage the operational South Seas forecasting team at the Met Office, and I'm the Northwest Shelf Marine Forecasting Centre's lead, monitoring forecasting centre. I've worked at the Met Office for about 15 years as a climate research scientist on the Northwest European Shelf Seas, but have now moved to the operational synoptic timescales. Okay. So today we're going to give an overview of the purpose and context of the Northwest Shelf MFC, give an overview of some of the Northwest Shelf products and the systems, how we produce the forecasts, and talk about the performance and usage of the data and some of the limitations. The Northwest Shelf MFC is a consortia with Met Office, BSH in Germany, the National Oceanography Centre in the UK, as well as the Plymouth Marine Laboratory, also in the UK. So as we've said, the Copernicus has the global domain and different regions, and this is where the Northwest Shelf region is here. The purpose of our MFC is to provide a marine analysis and forecasting service via real-time and delayed time production of physical and biogeochemistry data that is integrated as part of the marine Copernicus Marine Service. So we cover the Northwest Shelf, so that's the North Sea, the Celtic Sea, the Irish Sea, and the other sort of seas around that region. We use both models and observations combined in a operational production service environment to provide state-of-the-art reanalyses, analyses, and forecasts. So this is the yellow line is the Northwest Shelf. The yellow square shows the Northwest Shelf MFC region on the Copernicus grid. So we run two different model resolutions. We have a 7-kilometer lower resolution model called AMM7, which is outlined in red, and then a higher resolution 1.5 kilometer model named AMM15, which is the colored region. And you note both of them will fully cover the yellow region. So we run a daily analysis forecasting system and then the reanalysis system. The daily forecast system has a 2-day analysis period and then a 6-day forecast, producing daily means, hourly instantaneous values, and 15-minute high-frequency surface currents. The physical ocean parameters are on the 1.5 kilometer grid and the 7-kilometer grid. The biogeochemistry model is coupled to the lower resolution 7-kilometer model, and we also have a wave forecast based on the 1.5 kilometer grid. The reanalysis is run on the 7-kilometer grid, so the lower resolution, and for the physics it's back from 1992 until near present. The biogeochemistry is from 1998 until near present. We also have a wave reanalysis run on the 1.5 kilometer grid, which goes back from 1980 to near present. And these reanalyses are constantly updated, so they're updated to within about a month of real time. So to look at some of the variables, for the physical ocean, we have the sea surface height, 3D temperature and salinity, horizontal currents, and mixed layer depth. For ocean biogeochemistry, we have light attenuation coefficient, which is a proxy for visibility, chlorophyll, plankton, and primary production, oxygen, nitrate, phosphate, pH, and PCO2. For the waves, we have significant wave height, period, and direction, and we provide the parameters for the full wave spectrum, wind scene, and primary and secondary swell components. The modeling system we use is the FOAM model, which is the Forecasting Ocean Assimilation model. And we have two different versions. As I say, the high resolution AMM15 Atlantic margin model, 1.5 kilometer, and the lower resolution AMM7. So these are based on NEMO at about version 3.6. The high resolution model is coupled to WaveWatch 3 to give the wave models. And we use ERSM in the AMM7 model to give the biogeochemistry. The models are interpolated onto the Copernicus product grid to give regular lat long grid, 1.5 kilometer for AMM15, still on the 7 kilometer for AMM7. And they're interpolated onto Z levels, so horizontal levels in the vertical. So 33 levels for AMM15 and 24 levels for AMM7. Data assimilation is really important for keeping the model close to reality. So we use NEMO-VAR for our data assimilation. For the physical ocean, we assimilate observed temperature and salinity profiles, satellite in situ sea surface temperature, and satellite SSH, sea surface height. For ocean biogeochemistry, we assimilate satellite chlorophyll as ocean color. We are confident with our models beyond 5 kilometers of the coast and depths greater than 10 meters, and I'll come back to that later. Since May 2022, the Met Office uses the sea surface temperature from the high resolution AMM15 model and forecasts as the bottom boundary layer for our weather forecasts. So this gives, so we're really integrated into the whole Met Office forecasting system. The biogeochemistry model is ERSM. It's a lower trophic level model, biogeochemistry model, and it has 150 state variables with different plankton types and nutrients, etc. So we model all those components, their interactions, and the dispersion on the AMM15 grid. So it's quite an expensive component. I've talked about the products we provide and the constraint, the assimilation of ocean color. On the left here is this diagram of the state variables within OSM, so rather complex biogeochemistry model. We run the model at 2 different resolutions. The high resolution gives improved bathymetric impacts, so better representation of internal tides, topographic steering, and coastal effects. The lower left-hand side, you can start to see some of the internal waves that are captured by the AMM15 model. The improved resolutions give improved internal dynamics, which allow explicit resolution of eddies. And here you can see on the right-hand side the sort of improved current sort of fields that are modelled. But it's much more expensive to run, so we need to run the 7-kilometre model for the long reanalyses and also the biogeochemistry for both the forecasts and the reanalyses. The Northwest Shelf MFC reanalysis, analysis, and forecast are run on the same operational supercomputer that's used in the Met Office, so using the same technology and support infrastructure as used by the Met Office atmospheric weather predictions. I've said how important that data assimilation is for our models, and that we assimilate from satellite observations, in situ observations. Okay. So I'll try to give a bit of an overview of how we produce the forecasts. It's quite complicated. So we run 2 days of analysis, the previous 2 days. So we go back 2 days and run the NEMO model, and that ingests the observations and produces, as well as the model predictions, model observation pairs. They're fed into NEMO, which produces increments to improve the NEMO model, which is rerun. This produces the initial conditions for the day -1 analysis, and the same process is repeated. So running the model with the observations without the assimilation, doing the assimilation, then rerunning the models with the increments to improve the reality. So the day -2 is the best estimate because we've got the most time to produce, to accept as many observations as possible. And that's what is stored on Copernicus for the last two years. And then day -1 gives the most up-to-date analysis, and then that's run forward as the 6-day forecast on daily cycles. For AMM7, the low resolution model, NEMO and OSM are really tightly coupled, so that the whole process is done with NEMO OSM. With AMM15, the process is repeated, but WaveWatch 3 is not included in the analysis cycle. And here's sort of the time scales that the models are run on the supercomputer. So system performance and quality product are measured and documented in 2 forms. We have the near real-time system performance delivered via the Marine Service Product Quality Dashboard. And when we're developing the models, we do quite an extensive set of performance evaluation with the commissioning trials. This is documented in the product quality information document, the QUIDs. And for truth, we use for the product quality, we use observations in situ platforms, satellite observations. I'm sure you can look back at these slides later, so I won't go into all the details. But the sort of things we find is that for AMM15 physical ocean, we have temperature biases of about 0.2 degrees, 0.02 degrees, with an RMS difference of 0.43 degrees. And the M2 tide has an RMS difference amplitude of 9.8 centimeters and a phase of about 12 degrees. So we all know all models are wrong, but some are useful. The Copernicus Marine Service models are definitely useful, but it's worth being aware of the limitations of the data, and we've provided you some tips of how to use the products with your own research and services. So product quality information is a measure of model uncertainty. This information is limited by where we have observations. So where there's no observations, we can't test how accurate the model is. You've got to remember the model coastline. The coastline is a model boundary. So data right up against the grids of the cell can be used, but you have to think about how you use them. For example, if you've got an offshore wind we won't necessarily have waves properly developed in the coast box, the grid box right by the coast or along shore the coast. Also, we have a minimum depth on the model. So right now, the minimum depth of the mean water is 10 meters. So anywhere on the domain, the bathymetry less than 10 meters is set to 10 meters. Also, models have a limit of how high a frequency or spatial scale they can represent. And this is a representative scale. It's hard to define, but as a rule of thumb, you might factor 3 times the model grid scale or time step. So you need to manage your expectations in model performance in regions with strong spatial and temporal gradients. When using Copernicus marine data in conjunction with atmospheric data, there's usually correlations with the wind forcing the surface and the surface responding to the wind. So it makes sense to use the same atmospheric and marine data when you're doing it. So when you're using AMM15, we suggest that you use the ECMWF forecast or ERA 5, which we've used, if those correlations are important to you. Also important to remember that observations have errors too. And through Copernicus, these are very well evaluated. If you need more information that is available via the QUID, please get in contact with the service desk. The Met Office has been a proud contributor to the Copernicus Marine Service from 2015 to 2023. In the case of the marine forecasts, the data and product of the Northwest Shelf MFC, we can see the data being used in applications such as product warnings for public and emergency responders to coastal flooding hazards, safety of workers and infrastructure in the offshore energy sectors, monitoring and response to environmental pollution incidents, and search and rescue operations, understanding aquaculture response to change in the marine environment. We'd love to hear your applications. So that's all. Thank you very much.
Thank you very much, Jonathan. I think we'll have time to take a few questions. I'll try to share my screen.
Do you want me to share it, Erkan?
If you
have
can,
it right here.
yeah, sure.
Great. There you go. Yes.
Okay, great. Yeah, so maybe we'll take the 2 first questions. Jonathan, do you want maybe to answer them? It's a very precise question, the first one.
So we're unsure. It's very, very expensive to run, and we're not sure yet whether it's useful to keep. It would be nice to just have the AMM15 model and retire the AMM7, but there are reasons to keep them both models. It's very expensive to run biogeochemistry because you've got so many variables and so much being moved around. Another solution would perhaps be to run, use the physics from the 1.5 kilometer with the biogeochemistry at lower resolution. But right now it's not an immediate timescale. It's not really planned in the next few model updates, next few years anyway.
Okay, great. And for the second question, is there no data simulation for the wave in the AM15?
No, there's not, as far as I know. No, I think they're looking into it, but I don't think there's any plans immediately. I'm not 100% sure though, to be honest.
Okay. So that's it. I think we'll move on to the next presentation, but thank you. And once again, all the questions will be answered later.
Yes. Also to remind you that Rian will be also answering questions later on, the last part of the session. So now we will have a user testimony from Sergi Perez Jorge. Unfortunately, he couldn't be here with us live, but he sent us a beautiful presentation. I hope you can all see that. And we go.
Hi everyone, my name is Sergi Pérez Jorge and I work at the Institute of Marine Science Oceanus of the University of the Azores. In this presentation, I will talk about our case study, tracking whales in the North Atlantic. And sorry for not being present today, but I had another workshop. So, I would like to take you on a whale journey into the middle of the North Atlantic Ocean. Previous studies have shown that Azores is an important feeding area where baleen whales suspend their migration to forage, mainly between March and July. However, there is limited information about the migrations between this area and the productive areas in high latitudes, where they spend the summer feeding. And why? Because sampling is logistically complex and expensive. To overcome this challenge, telemetry data can be used to estimate these migration patterns and know more about their ecology. So, what have we done in this study? We used telemetry data to develop species distribution models. We tagged 3 different species around the Azores region: the sei whale, blue whale, and fin whale. The tags were used using the Spot 5 from wildlife computers. On the photo, you can see our colleague Rui Prieto tagging a blue whale. As you can see on the red circle, the tag is hitting on the surface of the blue whale. In this map, you can see the tracks of the 3 baleen whale species. In green, sei whale. In orange, fin whales, and in blue, the blue whales. In total, 31 tags that were placed from the Azores between 2008 and 2016. The mean duration of the tags ranged from 18 days for the fin whales to a mean duration of 36 days for the sei whales. Looking at the tracks, we observed that sei whales had a much more consistent pattern among individuals compared to fin and blue whales in orange and blue respectively. As we know, migrations and whale movements in general are closely tied with the distribution of their prey, in this case as ophacids, which is highly dynamic in time and in space. And in this photo, you can see a baleen whale feeding probably on ophacids along their migrations. Prey is the missing link to understand the distribution and behavior of baleen whales and other marine top predators, such as dolphins and sharks. Most species distribution models use variables as proxies of prey, such as depth and slope. But this is due mainly to the lack of specific information of prey biomass, mainly about zooplankton for baleen whales and micronecton for dolphins and other marine top predators, as we talked before, such as sharks. On recent years, or more recently, Copernicus has a new product that has provided us with the biomass of zooplankton and also 6 groups of micronecton. And this is based on the model developed by the CLS, the Cepodin model. This product has a global coverage at different spatial and temporal resolution, and it is currently available from the years of 2000 to the end of 2020. This is called the low and mid trophic levels, and it is a reanalysis for the global ocean. Then, for our study, we link our tracks to 9 static and dynamic variables, such as depth, distance to coast, or SST, and incorporated the zooplankton production and biomass from the Cepodin model, mainly for the years from 2001 to 2016. We then use the generalized additive models to find the relationship between the position of the whales and the environmental variables, or the prey biomass variables. And finally, we predicted the distribution of the 3 species based on this relationship at a monthly scale, at a resolution of 0.1. So now I will show you the prediction for each one of the 3 species. Here we have the predicted distribution for fin whales for the months of March to July, as these were the months that we had enough tracking data. Our maps show that the species move towards the northern latitudes where the zooplankton biomasses increases that area. And we can see here in red is the high preference for the species, and in blue is the low preference for the species. And we can see that the highest predictions occur above latitude 55 degrees north. In the Azores, the movement of the species is similar to previous reports from fisheries observers data that show us that the fin whales leave the area towards the end of June and July. On here, what we showed the monthly prediction for the blue whale species from the months of April to July. Looking at these maps, we see that the species has a preference for the mid-Atlantic ridge and moves along the month towards the Northeast Atlantic. Regarding the Azores, the probability decreases from April to July, and this matches with the observations obtained from two different sources, the fishery observers data and the whale watching companies. For sei whales, here we show the monthly maps from May to August, and this is the period where we had data for this species. And we see that the highest predictions occur along the Charlie-Gibbs fracture, that is around 50 degrees north, and also around the Labrador Sea, and it has been described as an important feeding area. We can also see on the maps that the Azores is not an important area for this species, for the sei whale, and this matches with our previous sighting records. But we think that the Azores is an important link between the feeding grounds in the Labrador Sea and the breeding grounds on the Northwest Africa, and this also matches with our diet studies based on stable isotopes. Now, if we compare our predictions with the only survey that was conducted along the Mid-Atlantic region in 2004, we see that the predictions match, as they also identify the Charlie-Gibbs fracture as an important area. Now, if we also compare with the predictions done by another study by Laura Manocchi from that they did in the Northwest Atlantic Ocean, we see that in both studies, even that they come from different sources, the Labrador Sea is also an important feeding area for the sei whales. In our study, we showed that the movement patterns of the three species were mainly influenced by two different variables: the temperature, the sea surface temperature, and also the zooplankton biomass. However, it's important to highlight that the relationship that we found between these variables and the presence of whales was different for each one of the species, and that's why we have a different distribution for each one of the species. As a summary, four main findings from this study. First, the integrating telemetry data with spatial explicit models can help us to understand the movement patterns from highly mobile species. Second, that the zooplankton biomass is an important variable to understand the distribution of these species. Third, that we need more prey data like zooplankton data, microplankton data from trawling and acoustic surveys to validate our biomass and microplankton estimates. And the last one, that this approach can be served as a tool to guide conservation and management decisions to assess the impact of different anthropogenic activities. Thank you very much to everyone.
So very nice presentation from Sergi. Unfortunately, he's not live with us today, but we will collect all the questions you have posted on Slido for Sergi, and we will answer them on the Padlet. And we will also have more answers for you at the end of this session, but also at the briefing session we will have in our third session. So now I will introduce our second user testimony, which is who's actually Ergan, food chef from Novelties, who's going to present us another use case. The floor is yours, Ergan.
Can you see my screen? Sorry. Yes. Okay, great. So yes, now it's my opportunity to present myself and my company and our activities besides organizing such workshops. So I will present you how we use the Copernicus Marine Service data with the user testimony about tidal energy assessment and our interactive tool that we call Tidy. So first of all, we'll introduce our company. We come from Noveltis, who is a French company based in Toulouse. We are almost 37 PhDs and engineers who work in scientific engineering for innovation. And we are involved in large-scale European and international projects. We work in the following fields, so in space, Earth observation, environment, sustainable development, and risk prevention. And so what I'm going to present you is about sustainable development. Since 2008, we have been developing several global and regional tidal atlases for the French and European space agencies. So we have developed the FES model, which are global models, and the very last one is FES 2022. And we also have developed regional models with much finer resolution, and we have one especially dedicated to the Northeast Atlantic, which is almost the same region as the Northwest Shelf. So we have been developing these atlases, these tidal atlases, mainly for altimetry purposes, but talking with our industrial clients, we have found out that they are also very interested in tides, and they are looking for marine applications about tides because tidal current is a great and promising source of energy, and it can be a very a great renewable energy, especially because tides are really predictable and consistent. And so talking with them, we found out about the need for resource assessment, and we developed Tidea, which is our tool to assess the ability to implant tidal turbines. And so globally, it's estimated that the tidal stream energy capacity could exceed 120 gigawatts. So as I said, it's a very promising source of energy. And so here the picture is wind turbines, which convert the current from tides into electricity. So now I'm going to talk to you briefly about how we build our tidal models and how we use the Copernicus data. First of all, our tide models are built in the spectral domain, meaning that we provide the amplitude and the phase of each tidal wave. So here on the left, you have the figure of the elevation of the tidal wave M2, and on the right of the phase. And so we do these maps for all the tidal waves, over 30 tidal waves. First, we build a hydrodynamic solution, resolving the equations, etc., with a fine-tuning of the three parameters, the bathymetry, the wave drag, and the bottom friction. And then that's when we use the CMEMS data, we assimilate the observation on our hydrodynamic solution, and then we validate we validate our model against some other data from the Copernicus service. So in the first part, we were using spectral atlases, but after that, we combine all our tide atlases to make tide predictions. So we make predictions for tide elevations and for tide currents. So that's the principle of how we can create tide atlases. More specifically, how we use the data. So as I said, we are using satellite and in-situ data. The experts have said that the Copernicus Marine Service provides a lot of data, and they are all very useful for tide modeling. And so here's an example of how we could use a specific tide gauge here in Brittany in France. On the picture on the left, you have the platform of the in-situ website where you can access the tide gauges. And so all the dots here are the tide gauges available. From this website, you can extract the time series. So here you have the time series of the sea level over a month. But of course, we are using much longer time series. And on this time series, we perform a harmonic analysis in order to retrieve for each tidal wave the amplitude and phase of of the station here. So these data enable us either to assimilate the models in our hydrodynamic solutions, that the model gets closer to the observation, and we are also able to validate our model in all the steps of the development. So that's how we use the data. But to go back to tidal currents, we have developed an interactive tool that's called Tidy in order, so as our clients are able to assess whether a location is relevant or not for, to set tidal turbines, sorry. And so you can access many indicators in regions where the bathymetry is lower than 100 meters. You can access the maximum current speed, the percentage of time when the current speed is higher than different thresholds. And also you can access the average power density. On the left, you have the map of the tidal current speed, and on the right, you have the power density. So all this information and many more are available on our website that's called InnovOcean. You can access also, so all our tidal models, global and regional. You have over 60 metocean parameters. You have user-friendly animated GIS maps, historical data and forecast, as I said, all our models. And so you can access for free most of the maps and the forecast for 4 days. But if you want to access the finest resolutions, the extreme event detection, and also the current energy assessment, you have to register as a premium user. And so, yeah, that's basically how it works. And if you have any question, do not hesitate to contact us either on our website or on LinkedIn or whatever. We'll be very, very happy to answer you. And I hope you enjoyed this short presentation on tide models.
Thank you again for your presentation. And I think we have a few questions already for you. I would share screen. Yes. So the first question, can you see my screen normally? Yeah, like this is better. So is someone who knows you, maybe? Okay. We know that little in situ on the tide is obtained on certain coastal areas. How to use the data validated on these areas by your models?
I'm not sure I really understand the question. If the question is about the quality of the data that we assimilate in our models, we really make sure like the processing, the editing of the data is very, very precise. And most of our work, a lot of our work consists in cleaning the data, and especially in coastal regions. But that's all I can say. I'm not sure that's the right answer to the question.
Yeah. Maybe the next one. What horizontal resolution are your tidal models?
Well, it depends on the models, but on the regional ones, we can go to the lowest resolution in coastal areas. It must be about 1 or 2 kilometers. So yeah, that's it.
Maybe we can answer more questions at the end as well, if you're still available. Great. And now I will give the floor to Cédric Jourdan. It's the user support manager of MarineData4NWS International, and he will tell you a bit more about the user corner and the learning materials. Hi, Cédric.
Yes, thank you, Andrea. So just a minute. 1 second. So you should see my screen.
Yes.
Yes, the Copernicus Marine website. So I'm Cédric from MarineData4NWS, and nice to meet you. I manage the user support team of the Copernicus Marine Service, and I will give you a short presentation of the user corner section. Sorry, it is an area dedicated to users, and this section contains many useful links to master our data and services. So to reach the user corner, it's on the top menu on the right. So you will find a different subsection. The first one is getting started. So as you can understand, it is the first page to visit with a sum up of the offer, the products, the ocean site report, the ocean indicators, and our OT visualization tools. And then a kind of operational path to master, to find the data, to visualize, to download, etc. So here you will find different useful links. The videos are not available, but because they are currently we are currently changing them, and so but all the available links are available and useful. So I come back to the user corner. The second section is Help Center and FAQ. So I will speak about later, because inside there are many articles to master the data and services, to download, to visualize, to be informed of operational events, etc. So I will show you later. The user notification service. It is a dedicated page to the operational events. So if there is an incident, a maintenance, or an improvement on a product or services, everything is written here. There you will find several sections, categories. So general, improvement, incidents, and maintenance. For example, if I click on improvement here, I will find a dedicated article about the last release at the end of November. The next one will be at the end of March. And if I click on the title, I have more details on the release with the dedicated documents about the notice and all the list of impacted products. And what is interesting in this section, in this page, that you can build your RSS feed. You specify your different filters, the region, the parameter, etc. You can specify as well a string of, for example, a title or an identifier of a product, and then you can make the view as an RSS feed, and you can subscribe this RSS feed. So, and I will show you how to be informed automatically of different operational events using this RSS feed, because there is an article in the Help Center. And the same for maintenance. So you can subscribe different RSS feed for maintenance, incident, etc. So you can see here that 4 maintenances are planned, and clicking on the title, you will find more detail on the maintenance. I come back to the user corner. User service learning service. Here you will find the different the future or the current events dedicated training for. Here is a link to this training. You will see you can see all the training sessions, past sessions, etc. The e-learning materials. Here you will find all the materials used during the trainings or anywhere else. You can select, you can sort using different filters, the level, the subject, the tool, etc. So you will find beginner, intermediate, and advanced level, different subjects, sorry, and different tools. So I'll let you discover all these materials, and other materials are available through the Help Center as well. I will show you later. Come back again to the user corner. The product quality dashboard. So this page, this section is dedicated to the quality of the Copernicus Marine products. You can sort here by area, Arctic, Baltic, etc. Northwest Shelf here. And you can sort as well the color of the ocean. So blue for physical, green for biochemical, and white for ice. And you will, you will find different expertises to explain the quality of the products, etc. So taking the validation expert metrics, you will have more graphs and more indicators. About the roadmap, here you will find what is planned at medium term for the Copernicus Marine Service. So for the moment, the last input concerns the November release, but you will find here inputs about the March release at the end of March 2023. Get inspired. Here you will find different use cases, how the user use our data. For example, the presentation made by Ergan before. So you can, as well here, you can sort by region, country, market, and or a string of characters. And clicking on the, for example, I select Northwest Shelf. Click the first one. If I click on the icon on the picture, I have details on the use of our data and the different products used, and useful links as well, and the benefits for users. So it's interesting because it can give you some examples of the use of our data, and so don't hesitate to check this section. To register, so it's easy to register, and it's free. So you need to be registered to download our data. And to register, you just need to give first and last name and an email, the country, type of organization, and blue markets. Accept the different aggregation, and then register. So the activation is automatic, but you will receive an email to validate your email address. So don't hesitate to check your spams, because sometimes this email goes to the spam. The service commitment and license. It is a document which explains all our commitment on the service, the time we have to answer to your request, etc. So everything is in this document. And a dedicated form to contact the user support. So as promised, I come back to the Help Center. In this Help Center, you will find many articles, more than 120 articles. They are sorted by collection, introduction, how to download, etc., visualization and manipulation. For example, if I click on the download section, you will find, or collection, sorry, you will find different sub-collection, how to download non-Copernicus Marine products, which APIs are provided, etc. And you click on the title. Everything is available here. You have a timetable and then a context, and then you will find many useful information in the articles. You can, sorry, at the bottom, you can say if you're happy or not with this article. And it's important for us because if an article is bad rated, we review it to propose a better version. So don't hesitate to send us your feedback. And for example, I spoke about the information about operational events. So if I want here to be how to be informed of the operational events on products and services. So I click on this title, and this article explains you how to receive automatic messages when your product is impacted by a release or an incident. So it's really, really important for you, because if you handle an operational service, it's very important to be informed in real time if a product is impacted. So another way to contact your support is the chat, the widget chat at the bottom right of each page of the Copernicus Marine service. So I click on the icon. Here, there are 3 different tabs. Home, you will find a direct link to the Help Center here. You can click on the top article, or specify here in the search the subject you need. So we can find here how to be informed. You select this one, and you can deploy the article. And this is the article. And I come back here. You will find here as well many useful information, news, etc. You can, of course, select this messages icon and send us a message, and you will meet Elena, David, or Martin, Anaïs, and you will see they are really, really friendly and efficient. So do not hesitate. And so it's that's all for me. So do not hesitate to contact us if you have any question, and we will be happy to answer you. Thank you.
Thank you, Cédric. Thank you. So I think a lot of the questions that were popping up during the session were already answered. Was really clear. And as you see, there's a lot of resources online for you. I think now we're gonna have Alex Omeran. Am I right? Yes,
that's it. That's me.
Tell us a little bit more
everyone.
about tomorrow's session. Welcome, Alex.
Are you sharing your screen, Andrea, or do you want us to do it?
Do it. Sorry, my
Thank
bad. Share screen, and that would be just 1 second, guys. Almost there. And yes, can you see my screen? Good.
Great. So hello, everyone. I'm Alexandre Brun from Noveltis also. Thank you again for attending this session. And now I'm going to briefly introduce you to the session that's going to take place tomorrow, our second day of training program. So those will be practical sessions where you will learn to manipulate the Siemens products using various tools. Perhaps, Andrea, you can go to the next slide. Okay, so first you will learn to use Python to manipulate the Siemens products. There will be a beginner session where I'll show you how to download the products. There are several ways to do this through Python. And then we'll do some basic manipulations, plotting data over a map, computing time series. And afterwards, there will be an advanced session in which we will study a particular scenario. We've chosen to show you the correlations of the trends of net primary production in the European Northwest Shelf. We'll study the trends in this region and how it can be correlated to other environmental parameters, which we'll also download from the Siemens platform. So here's an example of the plots that we will produce tomorrow. As you can see, there are many environmental that we're going to study. Yeah, you can go to the next slide. And so this is the screenshot of the MyOcean Viewer, it's a platform where you can visualize the products before downloading them. And next, in the second part of the second session, you will learn to use QGIS to manipulate the products. So you will need to install a plugin on QGIS, which is called NetCDF to GIS. In this session, so like in the beginner tutorial in Python, you will learn to access the data, create maps, create animation in QGIS with the Siemens products. And in the advanced tutorial, same as with Python, we will study a particular scenario. So in this training, it will be about river discharge into the ocean, in which we'll study many environmental parameters, salinity, nutrients. And this will allow us to plot various different maps, extract data at specific points, or show vector fields in QGIS. So we hope to see you tomorrow.
Thank you very much, Alexandre, for your presentation. I'm going to talk to you about the Padlet now. The link to the Padlet will be sent in the chat, and the Padlet gathers all the information about this workshop. I'll share my screen, maybe, Andrea. Here. Can you see my screen? Yes, great. Okay, so you have several sections. You can pin your location and tell us where you come from. And on tomorrow's session, we'll be happy to see where you all come from. You have the participant manual, many videos about how to access and how to use the Copernicus Marine Service. You have the tutorial videos, part of the content that will be presented tomorrow. You have all the e-learning material that Alexandre just presented. All the information and videos about the products, the use cases, and you will also find the replays, so the records of the video, the session of tomorrow and today's, and also you'll have the Q&A, all the answers that we'll make them available as soon as possible. That's it, I think, for the Padlet. Yeah. That's all.
Thank you. Thank you to both of you, Alexandre again. We are reaching the end of this session. We thought we could leave maybe if any of you want to stay a little bit longer and continue posting your questions, we will try to answer some of the questions that you submitted throughout the session. So we will try to do that now. I will open slide. Sorry about that. Exactly. And let's take a look at what we have. Can you? No, you cannot. Sorry about that. I cannot really open. Yes, maybe it's better. Technical problems. Okay. Can I? Yes. Oh, yeah. Okay. So we have a few questions. Let's read the first one. Do you expect us to have access to a working version of Python tomorrow, or can we also just follow along with it?
Do you want me to answer? Or
yes, go ahead.
Okay.
Go ahead.
All the exercises we'll present to you tomorrow that use Python, they will be on the Jupyter Hub, on the Copernicus Jupyter Hub. So you don't need to have your own version of Python, etc. So it will work just fine. The material will be online today, I think, and so you can have time. You may have time to do the exercises tomorrow. Well, before tomorrow, and tomorrow during the live session, you'll find the live presentation, and you'll be able to ask your questions if you didn't manage to do the exercises on your own. But no, you don't have to have a working version of Python.
Another question, there are some limitations in downloading big size data, and also some issues when submitting jobs for downloaded data. Is there any initiative for solve issues?
Yeah, these the several ways we have to download the data will be also presented tomorrow. We have the FTP solution, the MOTU solution. So yeah, plenty of solution for large data.
Can we scroll down to see if we have any other questions for other speakers, for example? One question for Cédric, maybe. If you're still there, Cédric. I used several Copernicus data in the Gulf of Guinea to study coastal circulation. How do you share this on your platform? I don't know if it's okay with you.
Can you see? Yeah.
Yeah.
If you want to share your experience, in fact, your use of our data, you can submit your use case. I can, if you go up, just a moment. If you go in the, I share my screen.
Yes. Also,
Yes.
so maybe you have to. Now you can do it.
Yeah. You can see it, yeah. In the
not yet, no.
Not yet, but
yes,
it will be. Okay. So in the left column here, you can submit your use case. You will have a different a specific form to upload files or title, etc., and explain give some details of your user's data, and the dedicated team will check and answer you. And then if the use case is validated, I don't know if it's the correct word, but your case will be added to the folio.
Perfect, thank you. Okay, so I think we can finish this session, and and maybe whomever wants to stay later on to respond to ask some more questions, but I think we are reaching our limit now.
Yeah.
So maybe we can close the session now, and whatever other questions that are left, we will try to answer them via the Padlet, and also to remind you, there's a debriefing session. So tomorrow we will have our practical session, but there's also going to be a debriefing session on the 15th of February, where we're going to have our experts again, and they will be able to answer more questions. The ones we were not able to answer now. Sorry about that. It's really nice to see everyone really excited and posting questions. That means you're interested.
Yes.
So thanks a lot.
And also thank you to all the experts which gave really great presentations today on very short notice. I'm really glad you all answered, and yeah, this was a really great session today.
Yes, thank you very much to everyone who came. Thanks a lot. Bye. See you tomorrow.
Bye.
Bye.